Yes, okay, that was a short video. I pressed again the wrong button on the pen. So yes, so we want to recap and go forward, which is we know that we want to make sense of the definition of the formula. Let's say big N I x n divided by n, and I want to claim that this is the this is roughly e to the ix. Okay, so let's see if and then we just remember that I to the x squared, for example, is minus x squared because it's I times I x squared, and therefore e to the I x to the cube is minus x squared because, well, let's do, sorry, I hope I'm not, I mean, it doesn't matter. I want to do step by step so that I don't make mistakes, But anyway, it's I squared times I, because we remember that the properties of exponent is that they sum, and you multiply two powers, you sum the exponent. So this is correct because they have the same base. Okay, and this is 3, 2 times 1, it's 3, so this is good. This is minus x squared times ix, which is minus ix cube. Okay, now we can go on we can go on by doing another couple of steps, just do, and then I will give a general view. So e to the 4 is now ix to the 3, ix, the same way we did the step before. Ix to the 3 is minus ix to the cube times ix. Now, minus I times I, x to the 4, minus I is exactly x to the 4. And the last step I want to do is, before I get a pattern out of it, maybe some of you already saw the pattern, but with the mess that I'm writing, it's maybe hard, so don't bother. Now, this is I to the 5, this is minus I to the cube, while this one is x to the 4, and this is x to the second power. Okay, there is something happening here. Okay, it looks like that when we raise to the power of when we raise I to the power of an even number, okay, 2n is always even, right? Because you can always divide it by 2. Any number multiplied by 2 is even. So e to the 2n is even, and this is either plus or minus. Can be plus or minus. In fact, for example, e to the 0 is 1, I to the 2 is minus 1, I to the 4 is again 1, and go on and on and on. I to the 6 is minus 1. As you can see, there is a double periodicity. So every so every 4 basically. And of course we know that, because if you think about the graph and the fact that 1 is here, how many times do we have to rotate? How many times do we have to rotate our so the rotation, if you remember, is multiplication by I, is a rotation by 90 degrees. How many times do we have to rotate to circle back? Exactly 4, because when we multiply 1 times I, we get here, and then we get here for another I, and then we get down there here for another I, and then we get back to 1 after 4 times. So 1, 2, 3, 4 exactly. One, two, three, 4. Yes. Am I doing correct? 0. Yes, of course. Because these are the even number, and there are the, of course, 2n plus 1, which are the odd numbers, which will be plus or minus. We get this plus or minus I, and in fact we will get that e to the 1 is I to the 3 is minus I to the 5 is again I to the 7 is again minus I. Yes, so sorry, this is, let me color this one. This is 1, and the red one is jump off twice. Okay, so the red one is a full multiplication of I. So let me do this with the solid jump of 2 i's. So I times I is actually 180 degrees, while to keep the color code, I times A is rotation of 90 degrees. Okay, and then we jump again by 2, but starting from a different point. So we get minus I, and we get this circle here, which is minus I and I and minus I. So, okay, so what I'm saying is that as you can see, this what I want to say is that